Yeah, so welcome everyone to my gym session. Yeah, I'm just going to be picking one. For now, I'll stick to easy problem at least for the next 5 sessions. Why is this thing slow like this? Oh my, oh my. So again, oh, what's this? Okay, remove outermost parenthesis. So this is one outermost, this is another outermost, this is another outermost. Um, how can I remove outermost parenthesis? Here there's okay, this is the only outermost that we have here. Let's see this. Oh, what you can see here is that the outermost is one. So you have to remove the outermost. So this two is going to be inside here. And this is another one. Yeah. So remove these parentheses and the one inside will be here. The same thing will be added. The same thing here. The two inside will be added first. Then this one has only one inside. This one has only one inside. And the other one too has I'm going to remove everything here and it has all this. So that's basically what you have to do. So basically I'm going to remove the outermost. And how best can we remove the outermost? Here is basically we're tracking the number of open parentheses. Like you're going to be using a stack. Push this to the stack. Push this to the stack. By the time we get here, you want to remove pop the top of the stack. How many elements are in the stack currently? There are more than one. Then just that's it means that that's not the outermost. The opening this parenthesis itself is not the outermost. But if it's just one, that means that's the outermost, which is not going to be included. But in case of something like this, or something like this self, like this whereby we push this to the stack, we have one, push this to the stack, we have two. We push this one out, that's going to be number one. Then push it to the stack, we have two. We push this to the stack. Oh, do I have to push to the stack if it's already one? No, since they've valid parentheses already, once I push to the stack, I have this it until this one is like satisfied. That's when I remove. Yeah, I think that's the valid solution. Let's go. Let's go. This is basically what I want to do. In this case, yeah. Well, let me. This one is one, two, and then this one is this. So in this case, so this is what I want to do. Go one by one. Push this one to the stack. Let me push something like here. Push the first one to the stack. Once I push to the stack, the second one, since there's something in the stack or the stack is already been filled already, I don't need to push it to the stack. The third element is a closing parenthesis. So since it's always a valid parenthesis, I'll just add it there. This one is also an opening parenthesis, and then there's already something in the stack. I'll, I'll add it to my string. This is the closing parenthesis I'm going to be. I'm always add closing parenthesis. Then this is another closing parenthesis. Oh, I said I always have to have closing parenthesis. This is another closing parenthesis. Then I'll check. This one does not relate to anyone, so I have to. It means that it belongs to the open parenthesis in the stack, so it won't be included. The second one, the stack is empty. Add to it, which means the second this one before I reach here because I already this closing parenthesis already removes the open its opening corresponding from the stack. So there's nothing in the stack yet. When once I get here, there's nothing in the stack. I put it inside the stack. Then another one, there's something in the stack already. By the time you get to this place, there's something in the stack. So I add it here. Then its corresponding closing is added right after it. Then there's another closing. There's no corresponding here already. So check the stack. Stack. It means that this one belongs to the open parenthesis in the stack. So I just remove the stack, and that's the end of our new limit. So sorry, the end of the string rather. So that's our new string. So that's basically what you're about to do now. Hopefully we don't shoot ourselves in the foot. string, uh, let me just say around that string called answer. We have to keep track of the parentheses that we have. Let me just say CLT for now. I don't know what's going to be doing. Stack, stack, char, yeah, stack char st. So for char c in this, all the characters in this. So check what you have to check first. If c equals if it's an open parenthesis, if it's equals an open parenthesis, these are the things you are going to do about it. You check if the stack is not if the stack is empty. If st dot empty, if st dot is empty, you're just going to push into the stack, push this into the stack if it is empty. But if it is not empty, what are we going to do? If it is not empty, you don't need to even do anything here. Just add, just add to the current string that we have, which is answer, answer. Just add it to the answer. Yeah, add it to the that's for opening parentheses. It's either opening or closing. So if it's not, if the C is not opening parentheses, the closing parentheses, what you have to do first, if it's a closing parenthesis, you have to check. Do you have to check? Oh, this is where I want to like be incrementing. I want to be incrementing CNT. Count the number of opening parentheses that we have in our answer. So that way I can keep track. So what I'm going to do is that if CNT equals to 0, which means you don't have any opening parentheses in the stack, it means that that one is it's not useful. If CNT equals to 0, the closing parenthesis is probably inside the stack. Sorry, the opening the corresponding opening parenthesis of the closing parenthesis, it's in the stack. I'm speaking to too many complexity. Okay, let me just run this code first. So I'm going to explain better. So if anything equals 0, continue. If it's not equals to 0, then add it to answer. Wow. It's even simpler than I thought. Add it to answer. Then decrement CNT. So you can keep track of ones that we've used. So after that, we are done. Just going to return our answer. Why do I keep typing ESN? Just going to return our answer. Blow me trumpets. Panari. Pam, pam, pam. How do I have to sacrifice chickens to eat good for this? Meat, yes. I've solved like 3 problems already. It's not. Um, why this thing is loading? Let me just run through what I've done with the. I think this one is the most complex example here. Basically, what you want to do is just remove the outer parenthesis. This is like an outer parenthesis. So we're only going to add the first and the second one. Okay, thank you. Let me see my implementation. The output. Oh, I completely forget the plus sign. My output is this. Why we want this one to be here? Plus plus plus. Okay, let me check again. This is my output and I want I think I'm not actually yeah. I'm only taking care of the first one. The other ones too are not working that way. So it's when we have an opening point. Oh, I'm not popping from the stack. If Saint is equals to 0, I need to pop before I continue. st.pop. I need to pop before I continue. So that way, the ones that because right now I'm not popping from the stack at all. So once I pop, yes, I guess it should work now. So let me go back to my explanation. For hopefully they don't tell me how this is the rate limit is kind of fun. Yeah, I knew it. Okay. So basically what I'm trying to do here, let me just try to explain. So this is like what is the best way to explain this? This is an outer parenthesis. We have one parenthesis, it encloses many parentheses inside it. An outer parenthesis, the first one I'm looking at. That's all the ones that are inside it are what? Let me just say, let me use this term, they are protected. So those are the protected ones are the ones that are going to be printed out. The second one is going to be deleted, but that's one that is protected, which is the third one here. The fourth one is going to be, sorry, the third one is going to be deleted, but it has how many protected ones? One, two, this, and this. So those are the things that I see here. So that's basically what's going on. Correct. So hopefully it works once. Accept. Yeah, the solution is not efficient. Why? It's not, it's not efficient at all. Is there any reason why it's not efficient? Is there anything I can come up with? Instead of using a stack, wait, do I have used a stack in the first instance? Hmm, once I see this one for the first time, ah, well, using a stack, well, if I still kind of use one integer or anything, it's still going to be the same thing. It's going to be the same thing. I can't really come up. Is there any hint for me to come up with? Can you find the primitive decomposition? The number of 70 characters must be equal. The number of these must be equal. Okay. Now, this. Once you have this, open. Maybe this is what, maybe I can do something like, I guess this recording is already going far. I don't want to spend too much time. It's already 12 minutes. The idea that I just have now is like, let me say opening, closing, these two. So keep track of the opening parenthesis and the closing parenthesis. Is that no. Keep this. Let me call this one outermost, and this one inner. So keep track. Once the first one is actually the outermost. So if there's any second one, it's going to keep on adding to the inner. So whenever I see a closing parenthesis, this closing parenthesis, once the inner is not yet zero, I add it. Yes, that's what I should do. That's another way of using, like doing it apart from using the stack. But that shouldn't give. I don't think that's this. It's the same time complexity. I don't think that can give any advantage. Or let me try to implement it. I'll be fast with that. So remove the stack. Let me just call this one int outer. Let me call it zero. It's outer zero, inner zero. If c equals this, hmm, if c equals this, you have to check. You have to check. You are not checking anything. If outer is already greater than, if outer is already greater than, sorry, if outer equals to zero currently, if outer equals to zero, then increment outer, um, else else inner plus plus and our answer, you add this to it. Yes. So the same thing here. Here I just checking. Let me just remove anything. So I don't have outer listing. If this is a closing parenthesis, first check if outer equals to 1, can't be more than 1. If outer equals to 1, so we are not going to use it. So I'm just going to decrement outer. Else, if outer is not 1. No. Sorry, did I say if outer is going to 1? This is supposed to be if inner. I would like to go this way. If inner is greater than 0. If inner is greater than 0, then add it to the answer here. Then inner decrement inner. That would be better. But if inner is not greater than 0, if inner is actually 0, then it has to decrement outer. That should be that should work. I okay. Hopefully I get the result fast. Correct. So I don't think it should affect the time complexity at all. Oh, is it because of using a stack? I well, I guess this time I'm able to do this. Okay, wow. Stack brings in a little wide there. So thank you. That's all for now. It's a good learning experience. Oh, nice, nice.